Hi everyone. Addressing your feedback from today's discussion about osmosis and the thermodynamics of osmosis, I had one question, which was a great sort of summary question. It was, what does free energy have to do with osmosis? So I can give you an example. If we look at the example that we had with this tube, where I had some solutions that were separated by a semi-permeable membrane, and over time what we observed happening is that the solution the liquid levels sort of creep up the tube, and the liquid is sort of lifted up the tube. Lifting the liquid, lifting the system, because that is essentially what's happening here, is that originally the center of mass of the system probably was right around here. I mean, it should be right in the middle for the center, and then you take into account that there's some mass here and there's some mass there. The center of mass initially is right here. After the reaction has happened, the center of mass is somewhat over here. So the liquid has been lifted up. And so you need to provide energy, you need to provide work to counteract the force of gravity and lift the liquid. That, again, takes energy. We didn't supply that energy from some outside force. We weren't personally forcing the liquid up. So where does that energy come from? That energy comes from the system giving up its free energy, increasing its entropy. So before there was lots of particles over here and relatively few over there. By shuffling particles from high concentration to low concentration, increasing entropy, that results in a decrease in free energy. That loss of free energy can be used, the free energy that the system is releasing can be used to do work on or by the system. So what does free energy have to do with osmosis? This is a specific example where the system can release its free energy to counteract the force of gravity and do gravitational potential work. So that is one way in which osmosis is somehow related to free energy. Osmosis is related to free energy primarily through the fact that osmosis results in an increase in the system's entropy. And since free energy is related to entropy, osmosis is therefore related to free energy. So yeah. Can you clarify what osmotic pressure is? Is it the energy that we have to exert to one side in order to stop osmosis? I will hand-wavingly say yes. We do make a distinction between energy and pressure. Your explanation is it the energy that we have to exert to one side to stop osmosis? And I would say that's exactly right, except replace energy with pressure. The idea is that naturally, the fact that you have a high concentration of solvent particles over here causes the solvent to move in that direction. If you want to counteract that, you need to exert some force, or if you take into account that the force is exerted over the entire cross-sectional area of the tube, it's the same as some pressure. And osmotic pressure is, yeah, how much pressure do you need to exert here to counteract the flow of solvent through the semi-permeable membrane. So you're right, it is how much you need to supply, how much you have to exert to stop osmosis, but technically it's the pressure that you need to exert, not the energy that you need to exert. So I hope that answers your question. And the last question here was, why should osmosis be a colligative property? So again, your question is, why should osmosis be a colligative property? I would say osmosis, this is a nitpicky detail, I admit, but osmosis is not a colligative property. Osmotic pressure is a colligative property. Osmotic pressure that a solution has is dependent on the concentration of that solution. or rather the concentration of solutes in that solution. Osmotic pressure, again, is how much you need to supply to counteract osmosis. Osmosis as a general phenomenon occurs because of the increase of entropy associated with water molecules, which is the solvent, moving from high concentration to low concentration. Again, it has to do with the concentration of the solvent in different parts. You have a high concentration of solvent over here, low concentration of solvent over there. That is what causes the liquid to flow this direction. The amount that it flows depends upon the difference in concentration for the solvent on the left side versus the right side. So again, osmotic pressure is primarily determined by this difference in concentration for the solvent. Again, it's dependent upon the concentration and it's dependent upon the concentration of the solvent. A colligative property is one which only depends on the concentration of the solute and not the identity of the solute. So to be more formally correct, osmosis and osmotic pressure depends upon concentration differences for the solvent, and it doesn't matter what the solutes are, it just matters that there are solutes, and as a result of the presence of solutes, the concentration of the solvent is lower. So again, that's why it's a colligative property, is that it depends on the solvent's identity and the solvent's concentration, not necessarily on the identity of the solutes. It's only dependent upon concentration differences, which again is one reason why it's a colligative property. One reason is that it's just that it's a colligative property, again, is that it's just based on concentrations. The other reason is that makes it a colligative property is that it's only dependent on the concentration of the solvent, and it doesn't really matter what these solutes are. So anyway, I hope that addresses all of your feedback questions. If you have others, please feel free to stop by during office hours. I'm always happy to help people and answer questions. Take care. I will see everybody on Wednesday.